Welcome to PreMath. In this video, we have got these two segments A, B, and CD fully confined in a big triangle PQR, as you can see in this given diagram, such that these segments A, B, C, D, and this segment QR are parallel to each other. And as a result, we get these three shaded regions, this green, yellow, and this purple shaded region. And the area of this green shaded region is being represented by S. Likewise, the area of this yellow shaded region is S, and finally the area of this purple shaded region is S as well. In other words, all these areas are equal. And furthermore, this segment QR is 21 units. And now our task is to calculate the sum of these two segments A, B, and CD, as you can see in this given equation. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. We know all these three lines are parallel to each other. Moreover, this line PQ and this line PR are transversal. So therefore, these angles are going to be our corresponding angles, and they are congruent. In other words, if this angle is alpha, likewise this angle is going to be alpha and alpha as well. And now let's focus on these angles. This angle, and these angle are all corresponding angles, and they are congruent as well. If I call this angle our angle beta, then this angle is going to be beta, and likewise this angle is going to be angle beta as well. And finally, if I call this angle gamma, then this angle is going to be common to all of these triangles. And here's our next step. Let's focus on this green triangle PAB and this big triangle PQR. Then we can see these two triangles PAB and triangle PQR are our similar triangles according to angle-angle similarity theorem. Then we are going to have a proportion. In other words, the ratio of this green triangle area and the total area of all these shaded regions is going to be equal to the square of this side length AB. So I'm going to write down this AB square divided by the square of this side length QR. So I can write down QR square. And please bear in mind that we are going to square these right sides since we are dealing with the area on the left hand side. And now we can see our this green shaded region area is simply 1s. So I'm going to write down 1 times s divided by the total area of all these regions. That means the triangle PQR area is going to be 3s. So I'm going to write down 3 times s equals to our this segment AB square divided by our segment QR square is going to be 21 square. And here we can see this s cancels out with this s, and we know 21 square is simply 441. So therefore we are ended up with AB square divided by 441 equals to 1 divided by 3. And now I am going to multiply both sides by 441 and the right hand side 441 as well. And here we can see this 441 cancels out with this one. So therefore AB square is going to be equal to 147. And I'm going to undo this square by taking a square root on both sides. So therefore our this segment AB length turns out to be 7 times square root of 3 units. So thus we have calculated our AB segment length as 7 times square root of 3. And now we are going to calculate the side CD as well. And here's our next step. Let's focus on this triangle PCD and the big triangle PQR. Then we can see that these two triangles, triangle PCD and the other triangle PQR, are similar triangles according to angle-angle similarity theorem. So therefore we are going to have a proportion. In other words, this green and yellow area combined. So I can write down green and yellow area divided by the total area of this triangle PQR is going to be equal to this segment CD. I'm going to write down CD square divided by this whole side QR whole square. Now we can see in the numerator this green and yellow area combined is going to be S plus S is going to make 2 times S. So therefore I can write down 2 times S divided by this total area of this triangle PQR is going to be S plus S plus S is going to give us 3 times S is going to be equal to CD square divided by our QR segment length is 21 whole square. And now we can see this S cancels out with this S. So therefore we can write down CD square divided by 21 square is going to be 441 is going to be equal to 2/3. And now we are going to multiply by 441 on the left hand side and 441 on the right hand side as well. And here we can see 441 and this 441, they are gone. So therefore CD square is going to be equal to, if we multiply the right hand side, that is going to give us 294. And now we are going to take the square root on both sides to undo this square. So therefore our CD length is going to be equal to 7 times square root of 6 units. And here's our final step. Let's go ahead and add these two segment lengths. Our AB length is 7 times square root of 3 plus our CD segment length is 7 times square root of 6 units. So thus our AB plus CD segment length turns out to be 7 times square root of 3 plus 7 times square root of 6 units. And that's going to be approximately equal to 29.27 units as well. And that's our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.